All right, boys and girls, welcome back for another live recording of the drive-thru here on this positive Wednesday. How you doing, Elena?
Good.
Yeah.
Yeah.
Welcome to the drive-thru. What do you have to say about it?
It's good.
Sorry, Elena. Okay, so again, I'm happy to do this one because it's about figuring out how to do the proof. So this is just like, how would I figure out how to do this proof? That's what a flow chart is. They used to do these things back in the 70s to help organize their thoughts. Okay? AF is congruent, is parallel. This is like what I'm talking about as far as it's not going to be as easy as this on the test. You're going to have to like look it over. So I know AF is parallel to EC. I know AF is congruent to EC. And I know that BE is congruent to FD. Okay. And before I even look at this flow chart, I'm going to kind of try to figure this out without the flow chart. How could I prove that that big thing is a parallelogram? Well, if I, the first thing I want to do is I want to figure out why they told me that these two were parallel. So what I do is I extend them. And then if I could just take this and make a blue line out of it. So I've got something that looks like that. So why is this angle congruent to that angle? Alternate interior. So that's why this angle is congruent to that angle. Okay, so I'm trying to make it look like a picture that I recognize. So AFE is congruent to CEF. I got that because AF is congruent to C is parallel, so that's what this is going to be. Angle AF. Well, here, let me just write it here. 1. Angle AFE is congruent to angle CEF. And list the reasons. So the reasons will be if lines are parallel, then alternate interior angles congruent. Okay, now the fact that given BE is congruent, that is going to lead us to say that BF is congruent to ED. I don't know if we're going to need that, but I think we might. And that's going to be segment subtraction. But I'm already getting ahead of myself, okay? I don't even like what I'm doing, so I'm going to step back. How would I prove it's a parallelogram? Well, let's see. I have to, if I prove that these two triangles were congruent, that would give me AD is congruent to BC. So I guess I'll just follow the flow proof. How would I prove that triangle AFB? I see it. I see what I did wrong now. I did number 1 wrong. I see it. I see it. I see it. This is not helping me. Do you understand that? I should have done this. And I didn't see that because I was looking at the top and the bottom triangles. So now I'm actually going to change this. I'm going to change this to alternate exterior angles. And I'm going to change this to AFB is congruent to CFD. And now I can prove that this triangle is congruent to that triangle in step 3 by SAS. All right. So now I got it. I understand. If I said that angle 2 was congruent to angle 3, what would be my reason for that? Yep. No, sorry, CPCTC, right? That's how I know that 2 is congruent to 3. But since 2 is congruent to 3, do you see the N there? Can you see that? So now what do we know? We know from step 5 that AB is parallel to CD. And how do we know that? Keep going, Kevin. You see the Z there? The N? Those are interior. So if alternate interior angles are congruent, then lines must be parallel. Okay? Alright, so let me undo my scribbles. Okay? We often forget that another really good way to prove something is a parallelogram is just prove that one set of sides is both what? Parallel and congruent. So that's going to be our next step right here. Step 6. AB is congruent to DC. And what allows me to say that? CPCTC. So I guess you could have included that up in step 4 if you wanted. And then finally, I know that ABC is a parallelogram, and my reason would be if one pair of sides is congruent and parallel, then a quad is a parallelogram. Hope that helps. Boom!